My name is Keith Edwards. I'm from Climate Reality Project. I think we're about ready to go. I'm ready for slides whenever you.
Okay.
So I'm glad to be here. I am just a little bit of background about like who I am. I am not a climate scientist, but I am talking about climate science today. I'm actually a marketer, and I volunteer with Climate Reality Project. We're an organization dedicated to education and giving kind of these sorts of slideshows and presentations at schools, at churches, at community organizations, just to kind of spread the reality about climate change. And so that's essentially like why I'm here today. And I'll talk a little bit about like who I am and my background, but basically and how I kind of got involved in this work. But I grew up in Oklahoma. I'm from Tulsa, Oklahoma, actually. My dad is an oil and gas lawyer, right? So I grew up with like, that was the kind of my background was coming from this family in Oklahoma. I don't know if you've been to Oklahoma, but it's like oil and gas is like the main industry there, and certainly like ours was our family's industry. And this is me, I'm the fat little kid playing at this was like our family's lake house. So I loved like playing outside, fishing, running around in the woods and everything. And what we've seen in Oklahoma, and coming from that perspective, right, is these incredible droughts over the past couple summers. So this is looking in 2013. The year before was 2012. It was equally bad in Oklahoma. 75% of the state was covered in exceptional drought. And that led to these tremendous wildfires that broke out and cost people lives and their homes and their livelihoods. And this was all kind of national news. And so I felt like these were my people, and we were being affected by things, and things were changing there. And so I wanted to get involved. Now I live here in New York. I'm actually a neighbor of Pratt, so I live over on Clinton Avenue. I'm like, what can I possibly do? And this is kind of what got me involved in this work and in talking a little bit about climate change and the effects that it's happening. And then, you know, in 2013 in Oklahoma as well, we experienced that massive wave of tornadoes. And they were right by where I went to school. And so obviously there are just these dramatic images coming out in total like devastation. And so that also kind of got me going into this work and really like got me involved in this. So from my like home state and then here living in New York, I wanted to get involved. I've met a lot of interesting people. Ta-da, that's me and Al Gore. So you know, it's been a really nice, thing for me to be involved in. I've gone back to my high school in Oklahoma and done this presentation. I've done to churches in Oklahoma. So it's been really a growing experience for me. And it's gotten me just really passionate about things. And I think that, so what I'm gonna do is I'm just gonna go through and kind of talk about some of the science behind climate change and then some of the effects that we're seeing today in terms of from a global perspective. This image is called Earthrise, and it was taken on Christmas Eve in 1971. And this was as the space shuttle had orbited the moon, and they saw Earth rising. And then this is the famous image of the Earth that was taken, and this was taken in the 1970s by the Apollo astronauts. And it was the first time that we had a picture of the entire Earth. And it's really beautiful. This is the most commonly published photograph throughout history. And actually, this was sort of the birth of the environmental movement in the 1970s. And this next little NASA animation is 30 seconds, and this is an entire day. And it's really beautiful, and it just helps us kind of think about the planet that we are all on and the scale of what we're talking about today. This next image is produced by NASA. This is an animation, so you see the years ticking off. We're in the 1890s, 1900s. Where it's blue is cooler than average, where it's white is average, and where it's gold or red is above average. And this animation will last, we're now into the 50s, into the 60s, 70s, 80s, and then up into 2013. It just gives a visual on the amount of heat that we're seeing across the globe. 14 of the 15 hottest years on record have occurred since 2000, and the hottest year ever measured is now 2014. And that's looking at global temperatures. 2014, to put into perspective, was the 38th consecutive year with a temperature above the 20th century average. So we're seeing that steady increasing in terms of the year over year. It may not be the hottest year or the hottest month. And we're also seeing that when we look at the month level. So February 2015 just became the 360th consecutive month with a global temperature above 20th century average. Now, as I was walking here today being hit by snow and it was freezing, I thought, well, great, that's a great time to talk about climate change and global warming. Of course, we all know that we have to draw that distinction between the weather and the climate. But I found this image last night and I actually thought I would throw it in today because I thought it was really interesting. This is from the NOAA, the National Oceanic Atmospheric Academy. And this talks about February 2015, which was the second warmest February ever recorded in history since 1880 when the thermometer was invented. And what they detected is each one of these dots on the map is a significant climate anomaly, including all of the snow that we got right here in the United States. And so this is kind of the theme of the presentation it speaks to, is I'll show around the world over the last couple years the different things that we've been seeing happening as a result of climate change. Here's global temperature by decade. You can just see in the 10-year increments how much hotter things have gotten in the last 30 years. And 4 independent records all show the same trend, which is it may go up, it may go down, but the trend is definitely up. So I'm going to talk a little bit about, just put on your like 8th grade earth sciences hat, why global warming happens and what's the basic science of it, right? If our earth were a globe about this size, then the entire atmosphere would be as thick as one coat of varnish and very delicate relative to the size of the planet layer. And what happens is, this is the basic greenhouse effect, and it's not new science, is that solar radiation in the form of light waves comes into our atmosphere, and most of that radiation is absorbed by the earth, and that warms it. And then some of it is radiated back into space as infrared waves. Some of it's trapped in there, and that gives us that nice average temperature of about 68 degrees. So what happens is, as we pump 200 million tons of carbon dioxide into the atmosphere every single day through a variety of sources, that thin layer of atmosphere becomes thicker, and therefore it traps more heat in the atmosphere. So that's the basic science, the basic greenhouse effect. And here's the trend that we've seen from global carbon emissions from fossil fuels since 1850. So we're now about 200 million tons of carbon dioxide and global warming pollution that's pumped into the atmosphere every day. Really, we still treat the atmosphere a lot like an open sewer. You know, you can sort of throw as much up there as you would like to. So, and that comes from a variety of sources, and we could spend a lot of time on this, but there's a lot of different things that contribute to that problem of carbon dioxide and global warming pollution. But what's interesting is 90% of the extra heat that's coming from global warming is being trapped by the oceans, right? We all know that the ocean like covers most of the land, and that is driving ocean heat content to a dramatic place. And so here's a measurement of the 5-year average, and you can see how much heat has increased in the ocean. And that is leading to sea surface temperature anomalies. So everywhere on this map that's red is where the ocean temperature is warmer than average. And that provides the backdrop for the typhoon that hit the Philippines in 2013. This was the most powerful storm ever recorded on Earth. And I know that we've all talked about it, seen it in the news, and the devastation in 2013 was tremendous. Some of the image of it are staggering. And 4 million people were displaced by this. So it's a you know, an important cost to human life. Now here is a look on October 29th, 2012 of that same surface temperature anomaly around the globe. So everywhere that's red is hotter than average. Everywhere that's blue is cooler than average. And you look, the red is 9 degrees Fahrenheit hotter. So that's a pretty big change. You kind of see something going on up in this northeast part of the United States. And that again provided the backdrop for Hurricane Sandy. So talk a little bit about that. Hurricane Sandy was the most powerful storm ever to hit the United States. It was the lowest barometric pressure ever recorded north of North Carolina. So it was the most powerful thing that we'd ever had in this region to our knowledge. It was it was a tremendous event. I know I was here for it. I'm sure many of you were and experienced it, and just all the different scenes of destruction. I have a little video about it as well.
This is what would happen to Manhattan. They can measure this precisely, just as the scientists could predict precisely how much water would reach the levees in New Orleans. The area where the World Trade Center Memorial is to be located would be underwater.
This is going to be a big and powerful storm. Millions of people are going to be affected all across the eastern seaboard, and everybody is taking the appropriate preparations. Our thoughts and prayers go out to all people who are potentially affected.
This extreme storm is related to the warmer ocean temperatures. Tropical storms get their energy from the ocean. Warmer oceans give it more energy.
An explosion at a Consolidated Edison power plant. More than 1 million people in 11 states are already without power. Breaking news now from the borough of Queens, New York, where a fire there has destroyed at least 50 homes.
The Battery Tunnel in lower Manhattan, this gets you out of the city. The tunnel totally flooded.
And now this water is rushing over the edge of lower Manhattan.
This was a devastating storm, maybe the worst that we have ever experienced. Many people have lost their homes.
The Hudson River, downtown Manhattan, was literally pouring into the ground zero site. All the infrastructure we have in this city is below ground. We don't have any built-in pumping capacity in the tunnel system. The electrical equipment in many cases is in the tunnel system, and now you have a serious problem. But I would expect a situation like this to occur, and I think we need a systemic solution long-term. As New Yorkers, we've gone through dark times before, and we know struggles, and we know crisis. And we come back even stronger, we work together, we work as a team. And the challenge here for us is not just to build back, but to build back better than before. Climate change is a reality. Extreme weather is a reality.
Powerful images. 8.6 million people were left without power as a result of Hurricane Sandy. It's also the most expensive storm that ever hit the United States. So when we talk about the cost associated with mitigating the effects of climate change, it's important to think about the cost of not doing anything to mitigate climate change. Let's talk a little bit about the linkage to the climate crisis and extreme weather events. So certainly no single activity caused a storm like Hurricane Sandy, right? And we wouldn't make that claim, but global warming is contributing to the background the increased incidence of all extreme weather, because we have a new normal. We have a new playing field on which these massive storms will develop and will grow. And so let's talk a little bit about that, what that is. And this is just a recap of the old hydrological cycle that we all learned back in Earth Sciences class, right? Evaporation, precipitation happens, and then water returns to the sea. And that's sort of that normal cycle. But what happens is, as the temperature increases, the oceans evaporate more moisture into the air, right? Because warmer air holds more water vapor, right? We have no hot water in my building right now. But if we did, when I take a hot shower in the morning, that's why my mirror fogs up, right? And then if I take a cold shower like I did today, it doesn't fog up. It's because of the heat that's involved. So it's a simple principle. With each 1 degree Celsius of temperature that you increase air, it's able to hold 7% more water vapor. Now that may not sound like a lot, but when we think about these massive basins of water vapor in the sky that seed a storm or a rain cloud, it's a tremendous amount of energy and a tremendous amount of more water in the air. There's already 4% more water vapor in the air than there was over 30 years ago over the ocean. So our atmosphere is 4% more humid than it was 30 years ago. And that's leading to that tremendous increase in a lot of precipitation. So this is a change in global temperature year by year. You can see that pattern that we talked about of increase really since 1940. And then there's a look at the increase in heavy precipitation days, and you see how those things really correlate and go together. So let's talk a little bit about larger downpours that are caused by those were out of order, but bigger and frequent floods. This is actually from Florida. This is a video from Florida. And this was in 2014. That was a little YouTube video, but that was from Pensacola, Florida, of just a flood, because they had 2 feet of water that fell in just a matter of hours. So it's a tremendous amount of simple rain. Here's a look at 5 feet of rain in 10 days in El Salvador in 2011. And really all over the world, we're seeing these massive downpours that are unprecedented flooding events in Pakistan. And Beijing has also had a lot of these in 2012, massive storms. And there's a lot of effects of climate change in China. In Nicaragua, 30,000 people affected by flooding last October. In Paraguay, in a single day, June 27th, they had a month's worth of a rain. And in Brazil, throughout South America. This is in India, 400% of rainfall. And I think that this next image is really kind of oddly beautiful, but just showing some of the effects in India. This is in 2013 as well. What we find is in developing countries and in different places in the world, they're less equipped than even we are to deal with many of these events. Both Koreas have experienced massive flooding as well, and in Mozambique. And then throughout Europe as well, in Greece. This is a really stylish image of a flood. And in Germany, 2013 for these. And also in the UK, there was a tremendous amount of, it was the wettest on record, 2013 to 14. And some of the effects of those rainstorms. Now that same extra heat that pulls that extra water vapor out of the oceans also has that same effect on the land. And so sort of the paradox of like all of the intense heat in the atmosphere is that while it causes these big downpours, it also causes longer and deeper droughts. And so we are seeing that same pattern of it rains a lot in places where it doesn't usually rain, and then it dries up in places that are accustomed to having rain. And so throughout the world, we're seeing this pattern. A quarter of Brazil's population has been affected by drought in 2015. This is last year in Brazil. Central America, you can see the map here of drought. It's tremendous. It's having a massive effect on corn and food supplies. Both Koreas experienced the worst drought in 100 years in 2012. This is the largest lake in China. And while this wasn't all due to a drought, there were some massive drought effects, but it was partially, of course, due to this deep drought. It's partially due to some irrigation and some issues as well, but it leaves a lot of people having to walk for miles and miles just to get water. So it really has a huge effect on people. You know, as I said, it dries up in places where it used to rain and rains in places where it used to dry. Here's a map of China. You could see everywhere that's bright on this map is a place that's really being intensely affected by a change. The red is where it's extremely dry, and then the blue is where it's extremely wet. Speaking of deep droughts, we got to talk about our own major drought issue, which is California. Anybody from California? Here we go. So 98% of the state is in drought. The images there are pretty staggering. This is taken actually in May of 2014. And typically they have 40 inches of snow, but in 2014 they had nothing. (2013) was the driest year on record. Now this is, the before and afters are pretty amazing. So this is a lake in July of 2011. And that's that same lake in August of 2014. It's at 32%. Here's Folsom Lake in 2011 and today. And the issue then, of course, is that with these dry droughts, that leads to an increase in wildfires. So we'll talk a little bit about hotter years are correlated to having more wildfires. We know this. Those tend to go together. And so we've had a rash of unusual wildfires in places that we all know and love and really respect. Australia has been plagued for years by different wildfires, and they've actually, their firefighters and first responders have done a lot to fight for new regulation on climate change. This is a great image that became kind of iconic for them. Touching a little bit on just desertification is a major issue, and arable land moving over into total deserts as we see those growing. And then this is a real interesting image taken just in downtown Phoenix, where a massive windstorm blew up these horrible dust storms. So this is also another effect of these deep droughts. You can see this as kind of a time-lapse image, but it's pretty amazing. And I like this quote from Colorado, because this is just, you know, a farmer out on the plains that says, look, things are changing. We've always had these, but this is becoming more frequent and more intense. And drought in Brazil as well. Essentially, this is very upsetting, because about 1 million square miles of vegetation, according to NASA, has been affected and continues to. So as of, it started in 2005. And we all know the importance of the rainforest to the planet overall. I'll talk a little bit. You know, we could do a whole afternoon on sea ice, but I think some of it's very interesting. In September, obviously, is when we have the least amount of ice, right? So that's after the summer, and that's when they measure the sea ice content. We can see that the trend here has gone to a new record low. And this is a little animation. And what we're finding is that the ice at the North Pole that is being depleted most is the ancient ice. So the oldest ice on this chart is white. So if you see where the white goes away, that's the ice that didn't used to melt at all. And that heartbeat is that's that freezing and thawing and freezing and thawing. That's kind of the heartbeat of the planet in a way. you guys can see, so then that's the years ticking on. We're in 2000 now. So this is from 1987 to 2013 is this animation. (2010). And so that's the before in 1987, and then 2013. Here's another image of 1984, and then 2012. In June, it hit 96 degrees in June in Alaska. Again, they've always had hot days, but that's unbelievable for that part of the world. And what's upsetting and disturbing is that when that permafrost and ancient sea ice melts, it actually emits methane gas. And this is flammable. I've seen scientists where they actually have footage and they'll light these things on fire. So that's methane gas, which is also contributes to the problem because that's another carbon emitting gas. Just a note about the cold too, is that there's a lot of evidence that the jet stream, as a result of all these changes at the pole, is becoming wavier, and that is having some effect on our current weather and current state, where that jet stream is dipping down more violently than it used to, causing some of the polar vortex that we've been suffering from. So again, it just speaks to, even though it's a cold day and we've had cold weather, it actually can indicate a bigger climate problem around the world. A look at some glaciers. These are pretty self-explanatory: 1880 and then 2005. 1978 and 2004. And then a word about Antarctica, just because Antarctica is what contributes to sea level rise, right? The ice in Antarctica sits on land as opposed to the North Pole where it sits on the water. So that you know, as these ice sheets in Antarctica change and melt, they will contribute to
Ice sheets rest on the ocean floor and can melt from both above and below sea level.
We have warm waters that are near those ice sheets. And if those warm waters actually touch the marine ice sheets melt, and you have big changes in sea level.
As the marine ice sheets melt, the land-based ice behind them moves more quickly toward the sea, and this poses the greatest threat for rapid sea level rise.
You know, and this is having a huge impact on places that are close to the ocean, which is why I included it here today. You know, warming oceans are making some parts of the world uninsurable, and nowhere is that more of an issue than right here at home. There's $129 billion worth of real estate in flood zones in New York City. So as we think about today, design, sustainable design, and things that we can do, understand that we're doing this and we're thinking about this on behalf of our own communities. It's really this, all of these global problems are here, and they're here for us right here today. We know we have to change. And the thing about global warming, pollution, and all of this is we have all of the technology that we need, but there's a tremendous cost to not acting.
So that is a pipeline that is busted and is flooded the neighborhood and is going all the way to the drain at the end of the street. Luckily, our house is here, which is seemingly unaffected, but the smell is unbelievable. I mean, look. Incredible, and that is oil.
So that's just somebody's YouTube clip, and you know, Arkansas, that looks like the neighborhood I grew up in as a kid. And there's a tremendous amount of a cost to our carbon-based economy. This is a quote that kind of drives me crazy. I want to talk a little bit about clean coal and the coal industry. You know, 1921 was when I have first record of talking about clean coal. We give our coal a cleaning. 1945, clean coal. 74, we're developing clean coal. 1979, can coal be cleaned? Yes, it can. 88, we were winning the battle for clean air. We're gonna have clean coal. 2009, clean coal is cool. Which this always reminds me of kind of another issue of like some questionable science. I don't know, it reminds us of, I don't know, this guy a little bit, you know, the sunglasses. the reality is that there is no such thing as clean coal. All coal and all use of coal is polluting and contributing to the problem of global warming and global warming pollution. Just some notes about the consensus on the issue. When we look at peer review papers, 9,000 plus, there was one that didn't agree. So for people to say that like there's no scientific consensus on this, well, that's really just not the case. And again, every major national academy of science in the world has confirmed and agreed that man-made global warming is happening. Those rejecting it there are none. So I want to talk a little bit about kind of some of the solutions to these problems. The G8 tells us that we have to act. As I mentioned, like, unlike, I don't know, Parkinson's or some other thing where we don't have the technology to address this problem, when it comes to this, we do. What we lack is the political will, but we have all of the solutions. And things are growing and changing at a rapid pace. In 2000, we projected that worldwide wind would reach 30 gigawatts by 2010. And the reality is that 2013, we had already done 10 times as much as that around the world. And then onshore wind cost, with all of these technologies, with cell phones or with photovoltaic solar cells, the more that they are used, the cheaper they become. And so we're seeing this dramatic drop in cost when it comes to wind energy. This is really interesting to me. The world's largest wind turbine, just one turbine powers 6,000 homes in Denmark. And then this is the London Array in England, which is an offshore wind farm that powers 470,000 homes. And then all around the world, we're seeing this tremendous development in terms of renewable energy. Morocco, in Ethiopia even. India is quadrupling its renewable energy. And in China, China's leading the world and leading the way in terms of many of this development, but a lot of it here at home. A little bit more about the projections on solar that we projected in 2002, they said the solar energy market will grow by 1 gigawatt per year. And the growth has been tremendously big, 17 times as much as was predicted. 2014, it was exceeded by 48 times. So we are seeing this massive growth in terms of solar, and this year it will be exceeded by 62 times. So finally, many of these things that we've been talking about are starting to take off. This is around the world of solar installations. You can see kind of that hockey stick, and the cost has gone down as well. And here's some of the neat applications of solar, and this is kind of brand new stuff, but in India, solar parity has been reached. That means that the cost of solar energy is the same as the cost of coal or carbon emitting fuels. Solar can also jump into different developing places, like this application in like Sierra Leone, where they have solar powered laptops, pay-as-you-go solar power in places that don't have an established power grid. So it's very interesting to see what's happening. And then I love talking about Ivanpah because this is actually a concentrating solar facility. So these are all mirrors that just direct the light up into a central tower that collects everything. And that is online as well. 1 million residential properties in Australia have solar systems. 1 in 7 homes is powered by solar in Australia. Germany does 3/4 of its electricity from solar and wind. And then looking at the US, at the number of installations for solar each year in megawatts, we can see the massive trend. I mean, there's a huge growing market here. 122% in 2011. And then that's for 2012. And then I mentioned India had solar grid parity, but just looking around the world at different countries that have that solar grid parity, and by year when they're projecting that they will have it. So again, it's that 1 degree, because I think as renewable energy decreases in cost, people will start to really use it as it makes financial sense. I think that's the key driver that will make a big difference. Here we go. The rest of the chart builds. So by 2020. For the first